The Rover 600, an exclusive range of four-door saloons offering style, prestige, outstanding quality, and powerful yet refined performance. The comprehensive model lineup will initially comprise of three exciting 2-litre derivatives, the 620 SI, SLI, and GSI. They'll soon be supplemented by the 620i and the joint flagships of the range, the 623 IS and the 623 GSI. In this video, we'll take a look at the Rover 600's powertrain, suspension, steering and braking systems, supplementary restraint system, as well as some of its electrical systems and body features. We'll start by taking a quick look around the engine compartment. On right-hand drive cars, the brake master cylinder and fluid reservoir will be at the rear right-hand side. Adjacent to that, on vehicles fitted with a manual gearbox, will be the clutch fluid reservoir. Also adjacent to the brake master cylinder is the main fuse relay box. If ABS is fitted, you'll find another fuse box in front of the suspension turret. This one houses several ABS fuses, as well as the ABS motor relay. In front of the battery, you'll find the coolant expansion tank. Then moving over to the left-hand side, you'll find the washer fluid reservoir. If it's fitted, the air conditioning receiver dryer, the power steering fluid reservoir, and behind that, on top of the inner wing, the vehicle identification plate. And to the rear, again, only if it's fitted, is the ABS modulator assembly. The engine compartment of left-hand drive cars is very similar, although for obvious reasons, the brake and clutch cylinders swap sides with the ABS modulator. Moving on to the power unit. The dipstick can be found at the front of the engine, which faces the left-hand side of the car. The engine number is stamped clearly on the forward face of the block, while the transmission number on both manual and automatics can be found on a sticker on the forward face of the transmission casing. All three engines used are completely new to Rover, although you'll immediately notice they all bear more than a passing resemblance to the 1.6 engines seen on the Rover 216 and 416 models. The 2-litre 16-valve single overhead cam unit fitted to the 620i produces 115 PS at 5,300 RPM. The unit fitted to the 620 SI, SLI and GSI models is a high-compression version of the same engine. Different cam profiles, together with different pistons, which create a higher compression, result in an increased power output of 131 PS at 5,400 RPM. The third and final engine used in the 623 models is the 2.3-litre double overhead cam unit. This unit puts out an impressive 158 PS at 5,800 RPM. All three engines use cylinder blocks produced using the new die casting or NDC method. That's where molten aluminium is injected into the mold at a much lower pressure than during a conventional casting process. This allows better control of the cooling and solidification processes, and in turn produces very high quality castings. Moving on. All three engines use a multi-layer metal cylinder head gasket. They all have 4 valves per cylinder. None are safe engines if the valve timing is incorrectly set. All rotate in an anti-clockwise direction. All have adjustable valve clearances, adjusted in the same way as those on the 1.6 engine. All use the refined and well-proven PGM-FI engine management system. And finally, they all feature 2 belt-driven balance shafts. These have been introduced to improve vehicle refinement and comfort. They're driven in opposite directions at twice the speed of the crankshaft. Their job is to help the crankshaft suppress the engine vibration generated by the pistons as they move up and down the cylinder bores. The timing belt and balancer shaft drive belt tensions are controlled individually by separate spring-loaded semi-automatic tensioners. These share a common location and are both locked in position by a single nut. To allow individual belt tensioning, the timing belt tensioner pulley can be locked in position using a 6mm bolt. Both belts should be replaced at 60,000 miles or 5 years, and neither belt requires any other routine maintenance. Now we'll look at a couple of features unique to the 2.3-litre engine. Firstly, the cylinder block is of the closed deck design. This means the deck, the machined face on the top of the block, has a large overall surface area. When compared to the open deck designed 2-litre block, you can see quite clearly much less of its surface area is given up for use as coolant passage. As a result, the 2.3-litre cylinder block possesses even greater rigidity. Another feature unique to the 2.3-litre block is the fibre-reinforced material, or FRM, cylinder liners. These are constructed using a mixture of carbon and aluminium oxide fibres, which are formed into a cylindrical shape. Liquid aluminium penetrates the compressed fibres during the casting process, creating cylinder liners which offer, when compared to cast iron liners, less friction, provide a higher resistance to wear, expand less when hot, dissipate heat better, and allow engine designers the luxury of being able to position the cylinder bores closer to each other. A word of warning though. The FRM liners are very sensitive to abrasion and are easily damaged, so be very careful when working in and around the bore area. Now, all Rover 600 models feature a hydraulically damped engine mounting. Each mounting operates like a simple shock absorber and consists of 2 oil-filled chambers connected by a small passage. Engine vibration is absorbed through the mounting by the oil as it passes from one chamber to the other. And because more engine movement is often noticeable on vehicles fitted with an automatic transmission, these vehicles use an electronically controlled hydraulic engine mounting. Again, the mounting consists of 2 oil-filled chambers connected by a passage. But in this version, the size of the passage can be changed. When idling, a large passage is provided, which allows the oil to travel easily between the 2 chambers. This softens the mounting and improves its damping efficiency. As soon as the engine speed increases, the size of the passage is reduced by movement of a rotary valve within the mounting. This makes it more difficult for the oil to travel from one chamber to the other, stiffening up the mounting, which will now perform like a normal hydraulic mount. All Rover 600s use the well-proven PGM-FI engine management system, which accurately controls both injector timing and ignition timing through a single electronic control module mounted below the carpet in the passenger footwell. With the exception of a couple of changes to the self-diagnosis feature and a few additional features on the twin overhead cam engine, it's almost identical to the PGM-FI systems you'll have seen before. Although you should note all Rover 600 models are fitted with an inertia switch mounted behind the front ashtray, which will cut off the fuel supply in the event of a sudden impact. The first new PGM-FI feature we'll look at is the variable intake manifold, which is only found on the 2.3. This helps refine engine performance and maximize engine torque during all types of driving conditions. It does this by making sure there's a strong intake airflow available at all times. At lower engine speeds, in this case anything below 4,800 RPM, it achieves this by delivering air to the engine through long, thin inlet tracts. To keep a strong intake airflow at engine speeds above 4,800 RPM, the ECM-controlled butterfly valves are opened, which also allows intake air through the shorter, fatter tracks. Also located on the inlet manifold is the air boost valve. This allows an additional amount of air into the engine during cranking and immediately after the engine has started. The extra air makes it possible for the engine to burn the extra fuel injected at this stage to aid starting, and so reduces emissions. And while on the topic of emissions, every 600 is equipped with a three-way closed-loop catalyst and heated oxygen sensor. Located in the exhaust manifold on both the 2 litres and in the exhaust downpipe on the 2.3s, they help improve exhaust emissions by reaching their operating temperature very quickly. The final feature we'll look at, again unique to the 2.3, is the double-circuit exhaust manifold. Here the exhaust pipes from number 1 and 4 cylinders and the pipes from 2 and 3 are paired together before they join in the downpipe. This helps reduce back pressure in the exhaust and offers the benefit of heating the catalyst to its operating temperature faster. Now onto the self-diagnosis side of the system. If a fault occurs in any part of the system monitored by the PGM-FI electronic control module, the orange malfunction indicator lamp on the instrument panel will illuminate. The fault code, or diagnostic trouble code as it's now called, is now displayed by the same malfunction indicator lamp on the instrument panel. To make it display the diagnostic trouble code, or DTC, you'll first need to locate and bridge the service connector. You'll find that midway down the left-hand A-post on right-hand drive cars and on the opposite side on left-hand drive models. Once bridged, switch on the ignition and count the flashes. The short blinks are still used to indicate single digits, while the long blinks still indicate 10. If there's more than one fault, the ECM will leave a gap of about 2 seconds between each trouble code. A complete diagnostic trouble code index is published in the service repair manual. To clear the ECM memory, just remove the 7.5 amp backup fuse in the engine compartment fuse box for more than 10 seconds. Microcheck together with Microlink should be used to carry out more thorough diagnosis on the PGM-FI system if required. And finally, just a quick mention of engine tuning. Like other PGM-FI systems, an idle speed adjustment screw located on the throttle body can be used to adjust the idle speed, while the ignition timing can be adjusted by loosening and rotating the distributor. So to summarize, the main features of the new engines are: the light alloy cylinder blocks are produced using the new die casting method. All 2-litre and 2.3-litre engines feature balance shafts to improve refinement. The 2.3-litre cylinder block features fibre-reinforced material liners and a closed deck design. All Rover 600s feature a hydraulically damped engine mounting, which will be electronically controlled on automatic cars. The 2.3-litre engine features variable intake, air boost valve and a double-circuit exhaust manifold. All 600s are fitted with heated oxygen sensors. The PGM-FI self-diagnosis feature is triggered through the service connector, and the diagnostic trouble codes are displayed on the instrument panel. Now on to transmissions. The same 5-speed manual gearbox is used in all versions of the 600. Although the gear ratios in 3rd, 4th and 5th will vary from model to model. The box has been developed from the box used in the 216/416 range. To improve shift quality, the third and fourth gear synchromesh capacities have been increased, and a main shaft brake has been added to eliminate the snagging that can sometimes be experienced when selecting reverse gear. It works during the first stage of selection, as the new synchro ring, which is locked to the main shaft via the synchro sleeve, is pushed against a tapered ring, which is locked to the gearbox casing by a stopper ring. This brakes the main shaft, bringing it to a standstill, allowing a clean engagement of reverse gear. And finally, you should note, instead of steel rods, 2 cables are used to connect the gear lever with the gearbox, a shift cable and a select cable. Servicing of the cables is limited to lubrication only, and if you do experience a problem with either cable, always replace them as a pair together with the housing. Now on to the automatic transmission. The transmission used is the E4AT electronically controlled 4-speed with torque converter lockup. And although it uses very similar technology to its predecessors, its construction is quite different. In addition to the main shaft and countershaft, it features an intermediary or secondary shaft. This 3-shaft construction allows for a much more compact design. Also new is the 7-point selector lever. Conventional park, reverse and neutral positions, and then D4, the equivalent to D or drive on older models. In this position, upshifts and downshifts will occur automatically through all 4 gears, and torque converter lockup is operational in 2nd, 3rd and 4th gears. In D3, gear changes occur through the first 3 gears only, and torque converter lockup is limited to 3rd gear. The sports mode, offering delayed upshifts, is also available in D4 and D3. 2, or second, will give you 2nd gear only and engine braking. And finally, 1, or first, will give you 1st gear only, again with engine braking. The engagement and control of the gears is electronically controlled by the Transmission Control Module, or TCM, which is located in the passenger's footwell, adjacent to the PGM-FI ECM. And this also incorporates a self-diagnosis system. In this case, the S light on the instrument panel will light if a fault occurs. And with the service connector bridged, it will flash the diagnostic trouble code. And remember, the PGM-FI and the E4AT circuits are interconnected, and some PGM-FI faults will make the S light come on, so always check out any indicated faults very carefully. To clear the TCM memory, remove the backup fuse in the underbonnet fuse box for more than 10 seconds. And like the PGM-FI system, Microcheck together with Microlink will allow you to check the system more thoroughly. Finally, there are 7 different pressure takeoff points strategically placed around the transmission. They'll help you diagnose and accurately identify problems when fault finding. To round up the main points of interest on the transmissions. The 5-speed manual gearbox used on all 600s is fitted with a variety of gear ratios. It has increased synchromesh capacities on 3rd and 4th gears. A main shaft brake is fitted to allow clean selection of reverse gear. And shift cables are used instead of rods. The automatic transmission used is the E4AT, which features a compact 3-shaft design. It features a new 7-position gear selector and provides the option of 1st gear hold. The transmission control module features a self-diagnosis facility, which is triggered through the service connector and displays the diagnostic trouble code on the instrument pack. Moving on. All Rover 600 models are fitted with speed proportional power steering that operates in the same way as the system used on the 827 range. The fluid level in the reservoir, which should be checked when the engine is cold, should be maintained using Unipart power steering fluid. Detailed checking and fault-finding procedures relating to the steering system can be found in the service repair manual. One other important point, vehicles equipped with a supplementary restraint system will have an airbag mounted in the middle of the steering wheel. So whenever working on or around the steering column, always follow the recommended precautions outlined in the service manual to prevent accidental detonation. Double wishbone type suspension is used at both the front and rear of the Rover 600. Its design allows it to absorb acceleration, cornering and braking forces, while at the same time keeping the wheels as perpendicular to the road surface as is possible. This maximizes grip and steering feel. The front suspension consists of a pressed steel upper arm, a knuckle or swivel hub, a lower arm, a radius rod, a combined gas and hydraulic damper and coil spring assembly, and finally an anti-roll bar. The wheel bearing is integrated into a housing which bolts to the swivel and is replaced as an assembly. And finally, there is a conventional drive flange and brake disc. The camber of the front suspension is not adjustable, but if necessary, caster angles can be altered by adding or removing shims from the forward radius rod mounting. The wheel alignment can be adjusted via the tie rods in the normal way. Now onto the rear. Here, the suspension consists of an upper arm, a knuckle, which houses the wheel bearing and hub, two unequal length lower arms, a combined gas and hydraulic damper and coil spring unit, a trailing arm, and again an anti-roll bar serves to improve the overall handling characteristics. The unusual length and shape of the rear knuckle allows the upper arm to be located further outboard than normal, which as a result allows for a larger boot space. You'll find the upper arms are stamped with an L or an R to identify left from right, while the longer and shorter lower arms are also identified and must only be fitted in their correct positions. The inner fixing bolt securing the shorter lower arm features two offset flanges. The rear wheel alignment can be adjusted by loosening the nut and simply turning the bolt, which will either pull the arm in or move it out. Finally, two notes of caution. If you're working on a hoist and intend to remove part or all the rear suspension, before you do, put some ballast in the boot to compensate for the uneven front to rear weight distribution. And if you're replacing a damper, always relieve its pressure by drilling a small hole through its body before you discard it. Now on to brakes. Rover 600s use a conventional servo-assisted, diagonally split braking system, which features ventilated discs at the front and non-vented discs at the rear. The ABS 6 anti-lock braking system is fitted to those vehicles which feature anti-lock brakes. Here again, it's a system which shares many similarities with the ALB systems seen on previous Rover models, and is almost identical to the ABS 6 system used on the 93 model year Rover 2 and 400 series. Like its predecessors, it's controlled by a single ECM, which you'll find mounted in the boot, where you'll also find the fail-safe relays. You'll also notice most ABS wiring connectors are colored orange, making them very easy to locate when fault-finding. You should be aware when starting a car equipped with ABS, a clunk may be heard from the modulator. This is due to the operation of the solenoid valves within the modulator and is entirely normal. The ABS 6 system displays its diagnostic trouble codes using the ABS light on the instrument panel. When the ECM detects a fault, the ABS light comes on and stays on. In this condition, the braking system will continue to work as normal, although there will be no anti-lock operation. To make the lamp display the diagnostic trouble code, bridge out the 2-pin service connector and switch the ignition on. The lamp will come on for 1 second and then go out for 2 seconds before it starts to flash the first code, leaving a 5-second gap before repeating the code or flashing a second code. Up to 3 faults can be stored at any one time. You'll find the trouble code index in the ABS section of the service repair manual. To clear the ECM's memory, you'll need to remove the 15-amp ABS fuse, B2 in the underbonnet fuse box, for more than 3 seconds. The ABS system can also be tested using microcheck together with microlink. When doing so, always follow the instructions given by microcheck carefully. And finally, the handbrake is adjustable and will require adjustment if the brake is not fully applied within 7 to 11 notches of handbrake lever movement. So the main points of the steering, suspension and braking systems are: all Rover 600s are fitted with speed proportional power assisted steering, which uses Unipart power steering fluid. Double wishbone suspension is used at the front and rear of all 600s. The caster of the front suspension is adjustable. The design of the rear suspension knuckle allows for a larger boot space. All the rear suspension arms are identified for position. And the rear wheel alignment can be adjusted by way of the shorter lower arm fixing bolts. The ABS 6 anti-lock braking system is used. Most of its electrical connectors are colored orange. The ABS 6 system incorporates a self-diagnosis facility, which is triggered through the service connector and displayed on the instrument panel. And finally, the parking brake should be fully applied within 7 to 11 notches of handbrake lever movement. Now on to another important safety feature available on selected Rover 600 models: the supplementary restraint system. The system works in conjunction with the seat belt and is designed to reduce driver injury during frontal impact when the force of the impact exceeds its preset minimum. The 600 uses the SRS-2 system, which is completely new to Rover, and unlike the SRS system currently available on the Rover 800, which uses separate components, this system incorporates all the various components in a single SRS unit located in the center of the steering wheel. The airbag itself is made from nylon coated with rubber on the inside and will inflate to its full capacity of about 40 litres in about 30 milliseconds. The bag has 2 large exhaust holes at the rear, which allows it to deflate almost as quickly as it inflates. This maximizes its cushioning effect and helps it dampen the body's movement. The SRS unit also houses the backup systems, which enhance the reliability of the airbag system, and the self-diagnosis facility, which will automatically inform the driver if a fault occurs in any part of the airbag circuit. During normal operation, the SRS light on the instrument panel will come on as the ignition is turned on. It'll then go out after about 6 seconds. At the same time, a red LED inside the SRS unit, visible only when the access panel on the left-hand side of the steering wheel is removed, will flash to confirm everything is okay. If a fault occurs, the SRS warning light will come on and stay on, and the LED will flash a diagnostic trouble code. It's recommended the system is checked and the cause of the fault rectified at the earliest possible opportunity, and this is also recommended if the SRS light fails to come on with the ignition. All Rover 600s are equipped with a sophisticated parametric alarm system, which protects against bypassing or unauthorized operation of the ignition switch, and against forced or unauthorized entry through any of the hinged panels. The system will be automatically pre-armed when the vehicle is locked, using the key in either door, or if remote locking is fitted, by locking the vehicle using the infrared handset. Incidentally, the infrared handset is not reprogrammable using microcheck. At this stage, the alarm system indicator lights located by the sill buttons in the front door trim panels will flash slowly. They won't flash, and the alarm won't be pre-armed if one or more of the panels is still open or if the key is still in the ignition when the vehicle's locked. If the vehicle is secure, then after 15 seconds, the system will move from its pre-armed state to its fully armed condition. At this stage, the indicator lamps will change from a slow flash to a fast blink. This fast blink confirms the alarm is fully armed, and because it's designed to act as a deterrent, will continue to flash until the system is disarmed. Once armed, the alarm will be triggered if any of the hinged panels are forced open, if any of the sill buttons are lifted, if either the bonnet or the boot release lever is pulled, if the ignition switch is turned on, if an ignition signal is detected, or if the battery is disconnected and reconnected. When triggered, the alarm will sound its horn and flash the indicators for about 30 seconds before going quiet. It will remain fully armed, and then, after a further 30 seconds, will trigger the alarm again if another unauthorized signal is detected. For convenience, access to the boot is allowed even when the alarm is fully armed, as long as the key is used to open it. And it's important to note, this will not disarm the whole alarm system, which will continue to protect the rest of the vehicle. Protection of the boot will be restored as soon as the boot lid is closed. And finally, the system can be fully disarmed by unlocking the vehicle using the key in either front door, or by using the infrared handset. To summarize this section of the program, selected Rover 600 models are fitted with an SRS-2 driver's side airbag. An SRS light on the instrument pack will illuminate if a fault occurs in the SRS system. All Rover 600s feature a parametric alarm system. Indicator lamps adjacent to the front door sill buttons blink to confirm when the alarm is armed. And access to the boot space is allowed without the need to disarm the alarm. Finally, we'll round up this program by briefly mentioning some other points of interest relevant to the Rover 600 range. Many of the body panels are zinc-coated to provide excellent corrosion resistance. And the body features tubular steel side impact bars welded into all four doors to increase passenger protection. Many of the plastic body parts are recyclable and are embossed with markings which identify exactly what type of plastic material it is they're made from. And staying with the environmental theme, the air conditioning system, which is standard equipment on selected models and available as a dealer-fitted kit across the rest of the 600 range, uses the CFC-free R134A refrigerant. A completely new range of security-coded in-car entertainment systems are available across the 600 range. The in-car entertainment handbook supplement includes a full operator's guide to the 3 sets available, as well as other useful ICE information. And finally, for further component and vehicle information and detailed service maintenance and repair instructions, refer to the Rover 600 Service Repair Manual. To increase your tally of ATP points, and for a chance to be one of 6 prize winners, read the booklet and complete the questionnaire that accompanies this program.